Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from March 2023, paper 2, variant 2. In this lesson, as always we will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. In the last video, we have already discussed question 1 and question 2. And for the solution of those questions, you can go to the channel and you can check for part 01. Let's study together. Let's improve together. For part A, we need to state two conditions for an object to be in equilibrium. Condition 1 is sum of all the forces in any direction has to be equal to 0. So we can say sum of all the forces in any direction has to be equal to 0, or simply you can say resultant force in any direction has to be equal to 0. So this is the first condition. And the second condition is net moment has to be equal to 0 about any point. Net moment is equal to 0 about any point. Now simply you can say clockwise moment has to be equal to counterclockwise moment about any point. So we can say about any point. I mean, if you choose any point and you take the net moment about that point, clockwise moment means the sum of clockwise moments has to be equal to sum of counterclockwise moments. So we can say about any point. So it's very important to understand the full concept. Not only if you remember net force is equal to 0, net moment is equal to 0, that is not complete answer. So you need to remember resultant force in any direction has to be 0, net moment about any point has to be 0. So for the answer of this question, simply we can say resultant force in any direction is 0, or you can say is equal to 0. In any direction is 0. So this one is the first condition. And the second condition is net moment about any point. Net moment about any point is 0. About any point is 0. So if you write down these two conditions, you will get 2 marks. And these are 2 B marks. I mean, if you write down the first one, you will get 1 B mark, and if you have written the second one, you will get another B mark. For part B, we need to show that the vertical component of the tension in the string is 13 newtons, and you can see value of tension is given to us, that is equal to 17 newtons in this case, and we need to find out its vertical component. So this is the horizontal component and this one is the vertical component. Question is asking us to calculate vertical component of tension. So we can say this one is TV, and TV in this case will be equal to T sine of 50 degrees. So simply in this case we need to write down TV means the vertical component of tension. This is equal to T sine of 50 degrees. And now simply you need to plug in values. We have 17 sine of 50 degrees. If we solve this one, our answer up to 2SF will be equal to 13 newtons. So this is value of TV. And this question has only 1 mark. If you have got the right answer, you will get 1 answer mark. For part C, question says by taking moments about end A, calculate weight W of the beam. So we need to calculate weight W of the beam and we need to take moments about this end. So in this case, first of all, we have already discussed that tension has 2 components. One is the vertical component of tension. So this is the vertical component of tension and this one is horizontal component of tension. So we have already calculated vertical component of tension TV, that was equal to 13 newtons. So now we need to take moments and we need to calculate value of W. So if we take moment about this point, so the moment due to weight, this one will be clockwise, and moment due to this weight also clockwise, and moment due to vertical component of tension, this one will be counterclockwise direction, but due to horizontal component, moment will be equal to 0 because line of action of force is just passing through the pivot point. So there is no perpendicular distance. So the moment due to this one will be equal to 0. Now simply we need to equate as this beam is in equilibrium. So we can say sum of clockwise moments. So first of all, we can write down clockwise moments. has to be equal to sum of counterclockwise moments. In this case, we have clockwise moment due to W, so we can write down W times, and the length of this beam is 0.5, so it means the distance from the weight to this beam, that one will be equal to 0.25. So we can say this one will be equal to 0.25 meters. So simply we can multiply this one with 0.25 meters. Plus moment due to this one is also clockwise, and the force is 12 newtons, and the distance from the pivot, perpendicular distance, that is equal to 0.35, and this one has to be equal to moment due to vertical component of tension times the distance from the pivot, perpendicular distance, and that distance is equal to 0.50. Now if we solve this one for W, we can find out value of W, and in this case value of W will be equal to 9.2 newtons. So this is our final answer, and this question has only 2 marks. The first mark is the C mark. If you have calculated values of the moment, you will get 1 C mark, and if you have got the right answer, you will also get answer mark. So this is how marks will be awarded to you. For part D, we need to calculate the magnitude of the vertical component of the force exerted on the beam by the hinge. Exerted on the beam by the hinge means the force on the beam at this point, and this force is by hinge. So we need to calculate vertical component of this force. So simply first of all, we can draw the arrow. So this force we need to find out. But in this question, we have also already discussed that there is a vertical component of tension that is acting vertically upwards. So this is vertical component of tension. Now in this case, as this beam is in equilibrium, so it means that sum of the forces along vertical has to be equal to 0. So in this case, we have 4 forces now. So we can say this force is F, let's say this force is F, and we can say this force is the hinge force, FH we can say, and this force we need to find out. In this case, we have vertical component of tension that is equal to 13 newtons, and we have weight that is equal to 9.2 newtons. These 2 forces are acting vertically downwards, and these 2 forces are acting vertically upwards. So the sum of upward forces has to be equal to sum of downwards forces. So simply in this case, we can say 9.2 means the weight plus 12 newtons. This one has to be equal to 13 plus force from the hinge on the beam. So we need to find out in this case value of FH. So FH in this case will be equal to 8 newtons. And so this is value of hinge force. So our final answer we can write down is 810 newtons. It's better to use 2 SF because in the raw data we have 2 SF. So this is our final answer. And this question has only 1 mark, and that is the answer mark. If you have got the right answer, you will get 1. For part E, it is given to us the block is now moved closer to end A of the beam. Mean this block is moved to the left. So we can simply imagine the block is somewhere here. So the 12 Newton force is acting at this point. So we can draw this is 12 Newton force. And it is also given to us that assume that the beam remains horizontal. If beam remains horizontal, it means that this angle also remains the same. So angle is still 50 degrees. So this is what we can conclude from remains in equilibrium. So angle also remains the same. State whether this change will increase, decrease, or have no effect on the horizontal component of the force exerted on the beam by the hinge. So we need to consider horizontal forces acting on the beam. So we have one horizontal force that is component of tension that is acting to the right. So it means that there is a component of hinge force that is acting to the left. And these 2 components, they have to be equal in magnitude. So let me draw this arrow again so you can compare the length of these 2 arrows. So the length of these 2 arrows have to be the same because beam is in equilibrium. So along horizontal, there is no net force. So these 2 arrows are equal in length, mean they have the same magnitude. Now the question is that how we can figure out what is the effect on horizontal component of the force exerted by the beam, exerted by the hinge on the beam. So how we can figure out that the effect on horizontal component? To figure out that one, we can take moment about point A. So we will start taking moment about point A, and then we will try to figure out the effect on horizontal component. So we will take moment about this point. Now if we take moment about this point, we have already discussed that vertical component of tension is producing counterclockwise moment. So in this case, we have this vertical component. This will produce counterclockwise moment, and this weight, this will produce clockwise moment, and this block will also produce clockwise moment. And if this beam is in equilibrium, so the moment due to weight 12 newtons and vertical component has to be equal. So simply you can say in this case clockwise moment, this has to be equal to counterclockwise moment. Means sum of clockwise moments has to be equal to sum of counterclockwise moments about point A, because we have assumed this is over pivot. So moment due to weight. Weight, we have calculated value of weight was 9.2, and we have to multiply with the distance from the pivot, and distance from the pivot in this case is 0.25, because beam is a uniform beam. So the weight of the beam is acting at the midpoint. Plus we need to add, in this case, plus means you need to add next clockwise moment. So we can just assume, actually before, let's say it was 0.35, now we can assume any value smaller than 0.35. So we can say in this case we have, this is 12 multiplied by, you can take any value. So let's say in this case we take 0.30, just assume, you can take anywhere, even without value we can do this one. So I will explain you how we can do without calculations. And this one has to be equal to the vertical component of the tension, that is equal to 17 sine of 50 degrees. We will just write down this, no need to write down 13, multiplied by its distance from the pivot, that is equal to 0.50. Now in this case simply we need to compare, we don't need to calculate. So in this case you can see, as this part decrease, it means this side also has to decrease. But you can see here, this one remains same, the angle in this case also remain same. So it means that the 17, it should not be 17. The tension should not be equal to 17. So the tension in this case has to be smaller than 17. So it has to be lower than 17 newtons now. So the tension has to be lower than 17 newtons. So we can conclude from here, because this side, the total moment decrease means the clockwise moment decrease. So the counterclockwise moment also has to decrease. But the distance of the vertical component of tension from the pivot remains same, angle remains same. It means tension itself has to decrease. A better way in this case, you can also write down T here. So you can say T has to decrease. You can write down 17, you can replace with T. So we have to say T has to decrease. If T decrease, how about effect on the horizontal component of tension? So we can say TH. TH has to be equal to T sine of 50 degrees. Now in this case, angle is the same, but T has decreased. So how about TH? So it means that TH, we can say the new value of TH, this one has to be lower than the original value of TH. So simply you can say TH in this case has been decreased. So this is how you can compare. So what is the effect on horizontal component of the force from the hinge on the beam? As horizontal component of tension has been decreased, it means as this component decreases, this component, horizontal component of the force from the hinge on the beam also decreases. So for answer of this question, simply you need to write down decreases. If you write down decreases, you will get in this case 1 mark, and that one is the B mark, decreases. So I hope this point is clear to you. If still you have any questions about this one, if this is not clear to you, just leave your questions in comments and I'll be answering as soon as possible. So let me explain you a little bit in a different way. I can even replace this 17 with value of T. So I can simply replace this one. So maybe this will make more sense to you. I can just write down here T. So if this decrease, how about the T? T has to decrease because angle is the same and the distance from the pivot is the same. So as T decreases, so we can write down T has to decrease. As T decreases, it means that the horizontal component has to decrease. As horizontal component of tension decreases, horizontal component of the force from the hinge on the beam also has to decrease because beam still in equilibrium. I hope this is clear to you. For question number 4, it is given to us two blocks slide directly towards each other along a frictionless horizontal surface as shown in figure 4.1. So these two blocks, they are sliding towards each other and the surface is frictionless as shown in figure 4.1. The blocks collide and then move as shown in figure 4.2. So we can see in figure 4.2 block X start moving backwards to the left and block Y continue moving to the left, and the momentums are given to us. It is given to us block X initially moves to the right with a momentum of this one, block Y initially moves to the left with this momentum. After the blocks collide, block X moves to the left back along its original path with a momentum of this. So this is momentum of block X. Block Y also moves to the left after the collision. For part A, we need to calculate block X as an initial kinetic energy of this, and we need to calculate mass of block X. So the first thing we need to understand in this case is we are talking about initial kinetic energy. Initial kinetic energy. So we have to take initial momentum, and this is initial momentum of block X. So we will take this is initial momentum of block X. We have kinetic energy. So you need to understand the way how to approach the problem. We have momentum of the block, we have kinetic energy of the block, and we need to calculate in this case mass. So we can start writing kinetic energy. Formula for kinetic energy we have, this is 1/2 mv square, and for the momentum E is equal to mv. Now somehow we need to connect these two together so we can figure out value of mass. So if we get kinetic energy formula, kinetic energy we can say this is 1/2 mv, and we can multiply this one with v. So we got here this is 1/2 mv is equal to momentum, so means mv, and we have v. But v from here we can also get v will be equal to p divided by m. So we have one p here and another p you can get from here because we don't have the value of speed, so we have to convert this one in terms of momentum. So we can write down speed in terms of momentum. So this v we can write down this is equal to p over m. Now you can see we have only three variables. Do we have the last one we can calculate, means mass we can calculate in this case. If we simplify this one, we can say this will be equal to p square divided by 2m. And for this question, we need to calculate mass. So we can rewrite once again. Kinetic energy, this is equal to p square divided by 2m. And from here, we can write down mass. Mass will be equal to p square divided by 2 times of kinetic energy. So now just you need to plug in values. Value for momentum we have that is equal to 0.37 square divided by 2 times kinetic energy, that is 0.30. So now if we simplify, we can find the value of mass. So the mass in this case will be equal to 0.23 kgs. So this is our final answer. A beautiful way to answer this question. And also you need to understand how we approach this problem. Means kinetic energy was given to us, momentum was given to us, and question was asking us to calculate mass. So how we can calculate? So you need to understand how to connect kinetic energy and momentum together so you can find out value of mass. So that's the reason we rearrange this equation. So we try to write down this one in form of momentum, mass, and kinetic energy so we can calculate value of mass. So this is how we have calculated value of mass. A beautiful way. Physics problem problem solving skills are very important. Not to always take the formula, plug in numbers. Take the formula, plug in numbers. Don't think about physics like that. Try to understand the situation. Try to connect things together. This is what questions are asking you. How you will connect these variables together. That's all. Data is given to you. Simply you need to understand how to connect them. Those connections you need to find out. I hope this question is clear to you. So the final answer is this. Final answer we have to write on up to 2SF because the raw data we have that has 2SF. Mean the least number of SF in the given data is 2SF. So we have to use 2SF in the final answer. You can use 2 or you can use 1 more. So this is the answer. So this question has 3 marks. So you will get 3 marks if you have written this one. For writing this, you will get 1 C mark, and for writing equation for the momentum, you will get another C mark. And the final mark is for the right answer. If you got the right answer, you will get 3 marks. So steps are very important. Always show your working so you can get the C marks. For part B, we need to determine the magnitude of the momentum of block Y after the collision. And this question is simply based on conservation of momentum. Because we have momentum before collision, if we calculate momentum after collision, momentum before and after has to be the same, because in this case there is no net external force acting on the system. So simply you can use conservation of momentum in this case. Momentum before has to be equal to momentum after. But we have to be very clear that momentum is a vector quantity. So we have to take one direction as positive. So in this case, we will take to the right is positive. If we take to the right is positive, this one will be positive. This one will be negative. This one also will be negative. And this is also to the right. We can say this momentum, let's say P, even you can say this is P, Y, and this one also has to be negative because this is to the left. Now simply we can add them together. So we have 0.37, we have plus, minus we have 0.65. This one has to be equal to minus 0.13, plus we have minus, this is P. So if we simplify, we can write down 0.37 minus 0.65. This has to be equal to minus 0.13. Minus sign is very important. Minus P. So we have to find out in this case value of P. So if we solve this one for value of P, we will also get negative answer. That one will be equal to 0.15 kgs meters per second. This answer will be negative. Means this momentum is negative because this is to the left and we have taken to the right positive. This question is simply asking you for the magnitude. So you can write down 0.15. And this question has only 1 mark. Answer mark. If you have got the right answer, you will get this mark. For part C, it is given to us block X exerts an average force of 7.7 newtons on block Y during the collision. Calculate the time that the blocks are in contact with each other. It's a beautiful question and also straightforward question. Why it is beautiful is because question is asking you to calculate how much time they will spend with each other when they exert force on each other. By simply knowing the force and the momentum change, we can find out how long they will spend together. It's a beautiful way. You can calculate time. So you need to visualize, little bit imagine the beauty of physics. So you can appreciate the beauty of physics, not just plug in numbers and calculate answers. Okay, so let's try to answer this question now. I hope you got some idea how beautiful physics is to explain the beauty of nature. So let's try to answer this question. In this question, it is given to us force block X exerts this much force on block Y. So simply, first of all, we can draw here. So we have block X and we have block Y. So in this case, it is given to us block X exerts a force on block Y. So this is the force by X on Y. And Y will also exert an equal force in magnitude, but in opposite direction on block X. So it means force on X is equal in magnitude to force on Y, but they have opposite directions. So we can take any one of them. We can take block X or we can take block Y and we can calculate time. So in this case, I'll be taking block X. So I will be looking at this block only, this block. So the net force exerted on the block means F net. This is equal to delta P over delta T. So the force exerted is given to us, that is equal to 7.7 newtons. And in this case, we need to calculate the change in momentum. So for block X, the change in momentum. So you see this direction is to the right and this one is to the left. So we have to take one direction as positive. So we will take in this case to the right is positive. To the right is positive. If we take to the right is positive, that will work. But I will take in this case to the left is positive. I'll be taking to the left is positive. Why I'm taking to the left is positive? Because the force on the block X is to the left. When it will collide, so this one is block X, this is block Y. So when block will collide with each other, this is block X, this one is block X. So when it will collide with block Y will apply force on X in the opposite direction. So the force on X will be to the left. So that's the reason I'm taking to the left is positive. So the final answer also will be positive. And so this force is positive. We are taking to the left is positive. So the force is positive. So we need to calculate change in momentum. So in this case, this is our final momentum. So we can say P final minus P initial over delta T. So a little bit in detail so you can get better idea. So we have P final, that is positive 0.13, and we have minus, and this momentum is negative because this is to the right, divided by delta T. So simply we can say this is 0.13 plus 0. This is also negative. So negative, positive, divided by delta T. Now if we solve this one for delta T, and so we can get the value of T. I'll be writing here now. So delta T in this case will be equal to 0.13 plus 0.37 divided by 7.7. So we can find out the value of delta T. Delta T in this case will be equal to 0.065 seconds. So this is our final answer up to 2SF, because in the raw data we have 2SF. This has 2SF, this also has 2SF, this also has 2SF. So the least number of SF in raw data equal to 2SF. So the final answer should have 2SF as well. So this is our final answer. And this question has 2 marks. The 1 mark you will get if you have written this step. If you have written this step, you will get 1 C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks for this question. And this is end of this video. And I hope these questions are clear to you. If these questions make sense to you, and if you find this video helpful, please like and subscribe, because your encouragement is very important so I can make more videos for you. See you next video.